Um, Hello, everyone. So my name is Pierre Gutierrez, and today I'm going to talk about how to extract information from images on your website and how to actually use this information to improve the quality of your recommendation engine. So first, I'm going to talk a bit about the context. Then I'll detail some basics about recommendation engine. And then we'll talk about labeling images, how to pre-process and post-process this information. And at the very end, I'll show some results with many images. All right, so who I am the data scientist at Dataiku. What we do at Dataiku is we try to edit the best platform for data scientists as well as data analysts. And if you're interested in this, you can talk to me after about that. So in this context, we tend to work with a lot of different clients. And one of the missions that I did with my team was to work with these e-business vacation retailers. So what they do is they have salespeople that will negotiate the best price with tour operator and hostels in order to get these products which are packaged discount luxury trips. So they have millions of clients and they have hundreds of these kind of sales that are open on their website every day. So of course they need a recommendation engine, and especially because the marketing over there believes that the purchase on this website is really impulsive. You don't go to this website in order to say, okay, I'm going to go 2 weeks in Rio at this time of year. What you're going to see is more like, okay, I have 3 days next weekend. Where should I go? Oh, there is a nice opportunity to go to London. So maybe I'll purchase this. So that's the idea, which leads to some specificities when we talk about recommendation engine. It's kind of close to what we saw this morning with the news recommendation. There is a highly temporary feature. Each of these products, they stay on the website for 1 week maximum. So it means that you cannot really use classical recommender system because the matrix will be really, really sparse. And also that you have, all of these sales are really seasonal. So you cannot really sell ski during the summer. And Punta Cana, for example, will be more sold in France during the summer. Second thing is the product can be really expensive. You can see here 1,700 euros for a trip in Peru, in Machu Picchu. So of course you have few recurrent buyers, which means that the information that you want to capture is mostly the visits and the clicks. Right, so before we actually start talking about images, I want to say that we did not start by doing some recommendation in the image because that would not make sense. Though there is some information. What we want to do is start with a simple modeling that we can put into production and quickly A/B test. Right? So we started with the basic ones, collaborative filtering and content base. So for those of you who are not familiar with it, the idea of collaborative filtering is to recommend to similar users something that one person liked and the other didn't know about. And how do you determine if some people are similar? You just look at their preference, purchase, what they visited. So in this case, typically these guys went to Kenya and Peru. This person also liked a trip in Thailand, so you will recommend Thailand to the second person. Content base, however, would be you like things in New York or in Chicago, and I'm going to display to you new sales that are similar because they are typically in New York or Chicago during only one weekend. But of course, as we said before, there are many other factors that can affect the quality of the recommendation. Typically, retargeting, which is a person already visited this product. I want to display to him again because there is a chance that he actually wants to purchase it. External factors, such as the season for skiing and popularity. So how do we combine everything? What we choose to do is to do a meta model. So basically, we generate all of these recommendation engines And we use that as feature to train a logistic regression that we try to predict directly if someone will purchase the product, the sale, or not. So basically, it's like if we took all of our recommendation engine that I talked about previously, and we just combine them using some optimized weights. Right. So this is the first iteration that we did without images, and basically we score every client against every product that will be open on the following day. So around some 1 or 2 million clients against 700 products. We do that every night by batch using Impala and Spark. And this generated plus 7% revenue per day. So we were really happy about that. Now, what we want to do is also use some sale information. And why is that? This is because if I just look at the content of my sale, what I have for the first one, for example, is ski. This is the theme. But you can see I'm not selling the same stuff on the 3 images. So that would be 3 different products. On the first one, I'm kind of selling the adventure, the sport, the ski. On the second one, I'm selling maybe the party at the ski station after the ski. And on the third one, I'm selling the comfort after the party, after the ski, right? Same for the second image here. First one would be nature. Second one is the south of France. So it's more like party, drinking, and so on. Third one is I'm selling the hotel and the pool. Probably the person will never go to the beach. He's just interested by the pool, right? So that's why I want to get some information about the images. So what if I had a model that could predict what I have on the images? Then what I could do is create a vector for each of the image with tags. So that could be, for example, for the first one, I can say that there is sea, beach, forest, and a hotel on the bottom. This will give me a description. From all this description, I can generate vectors. If I have vectors, I can calculate similarities. If I can calculate similarities between sales, then I can use that again in a content-based recommendation engine that I can take into account in my meta model, right? So that would be one of the features, not the best one, but probably one with a lot of information. So how do we did that? So as people said this morning, there are some issues with deep learning. So first, you have to get some architecture, some GPUs. Then you have to get some people that actually know how deep learning works. You have to take some time because some model can, you may need 72 hours to train some models, and then you will have a lot of labeled data. In our case, we don't really have labeled data. That's a big problem because the labels that we have are these ones. So they do not separate one of the sales from each other for the ski, for example. So I'm lacking my information. So how can we solve these problems? Well, you do like every data scientist, you go on Google and you look for similar stuff. So what can you find? Oh, it's down. Yes? Okay, perfect. So in our case, we started by having a look at similar data with labels. On the left, we have our data set that we need to label. And then there is the places data set with 2.5 million images and the sun data set with only 100K images, right? So if we manage to get a model working on this and a model working on this, then we can assume that we are able to generate some very interesting labels for our private images. And so the good thing is, if you have data set with images, there is probably someone that did the work for you. So you can check at the pre-trained models. And so typically, here we took a look at Cafe Model Zoo, and we find a pre-trained model. So you can see that if we apply that to these two pictures, then we get, we get some good information, like swimming pool and the fact that there's a hotel. So that's nice. Now, what we actually want to do is use the Sun database to generate more labels. Now we have an issue because on Sun database we didn't find any pre-trained models. So we actually have to do some work. Turns out, if you have already one pre-trained model, you can use what we call transfer learning, which is basically using the first model as a feature extractor to learn more easily a second model on the second dataset. So the idea is the following. That would be something from an example on ImageNet. So you train your first model over there, and then you want to use this model to extract some information. So what you're going to do is just freeze all of these layers, cut the final layers, and retrain a model going like all the images through the network. And so all the images are now in a space where you have rich features, right? So even with a common SVM, you can obtain very good results without having to retrain any deep learning model or to choose your architecture. If you have a lot of data, you can also fine-tune, so either part of the network or the whole network, right? But this is actually not what we did. So just a bit of code. I have a GitHub, so you can ask me after if you want to look at that. But basically right now, transfer learning is really easy to do. It's like a few lines of code. If you just want to use as feature extractor, 5 lines, and you have your new models using Keras. So it's really easy. So I encourage you to try. So what we did was this setup. We have places, pre-trained model. Then we can use transfer learning to have the Sun database in a new space with rich feature. And then we can train on top of that a small network with 2 hidden layers, right? And now we have this new layer, new model. We can apply that to our images. So now we have both models, one on places, one on Sun database, which give us a lot of different labels to use. Turns out, interesting things, what we have top 5 accuracy on Sun database using this transfer learning is more than the best architecture, state of the art that you would have only using Sun database. So it proves that not only it's easier to work with transfer learning, but also it's very important because it will give you better results, right? So don't start with weight that are from scratch, just use some pre-trained models. Okay, so now we are not finished yet because what we have is a classification problem. We just have is it a pool or not with a probability. And it's not giving me exactly what I have on the image. So I don't have my vector. I don't have my similarity yet. So how can I post-treat these results? So basically what we did was we kept the 5 first probabilities for each of the classifier. So example on the left, I got a vector describing my image that is 1 on the islet, 1 coast, 1 sandbar, 1 ocean, 1 sky, and 0 elsewhere, right? So it's not that bad. There is an issue though. It's that we may have some redundant information. So on the left, I do have 5 different information that characterize my image. So I'm quite happy. On the right side here, the 5 are the same. So it's annoying because now if I have, let's say, a picture where I would have just 1 tree inside this room, then this image would be 5 times as more correlated with this one than with this one. So what I'm doing is I'm creating a space that is highly unbalanced, and so my similarity will not be really balanced, and thus my content-based recommendation engine might have problem. So what did we do? We use matrix factorization, NMF from scikit-learn. So again, 3 lines of code, really easy. And it has some good features. First, reduction of dimension, which makes our whole pipeline faster. And then it balances the vectors. So for each theme, I now have one dimension, which means that the similarity that I'm going to use actually makes sense. Other thing is we get explainability. So typically, if we look at the bigger themes that we have the ocean coast, we have the bridge viaduct river, we have the hotel room, bedroom, dorm room. So these are themes that can be interpreted by the marketing team. So it means that the marketing team will say, oh yes, actually your stuff works, so I'm having no problem in putting that into production, which is nice. All right, so this is the results that we get from this NMF. And we can see that for the first image, it's for what we want to do is perfect, because we get the fact that is the outside of the hotel, we get the fact that is a pool, we get the fact that we have some green golf, we don't really know, and on the very end of the picture, you can see that we have the coast. So it details exactly what we have on the image, so we can use that for similarity purposes. So two things to notice here. First one is, as I said, there is a goal for putting green on the first image. Maybe it's not. Do we care? No, we don't. And why? It's because we use the tags of the images to create similarities. So if that stuff was called a cat, that would be the same, except if we have real cat pictures, which we don't. Okay, so it's not really important if it's considered a golf or not. Second thing is, what about the performance of the neural network we use? Do we really care? The reason is not that much, because what's the probability that if I get a better model, improve my accuracy by 1%, it actually modifies something? Because my neural network is used to generate labels, just 5 labels. Then these labels are put in an NMF to generate themes. These themes are used to generate similarities in content-based in the meta model, and the meta model is used to display 10 recommendations. So if I move by 1% the quality of my neural network, it won't change anything. So we don't have to have we have state-of-the-art results, but we don't need to have the best results ever. Right, and so to conclude, some results. So here you can see 4 columns, and the first one is the visits that user did. The second one is what we're going to recommend with the first iteration of the meta model recommendation engine. Third one is only based on the images, and the fourth one is the combination of these two. So you can see on the first column that the person clicked only on pool hotels. And that, so maybe you cannot see, but most of the sales are actually for France or Morocco. So then we recommend things, and you can see that, well, again, you cannot see, but most of the things are for France or Morocco. So we get the right destination, we get the right budget, so it makes sense. However, what we display to the person is this kind of countryside house, which is still something supposed to be sun and beach, but it does not really match, right? And same here, we have some Versailles castle or Brandebourg Gate. I don't know, but it does not look like a pool. Then third column, the problem that we have is, of course, all of these pictures are really nice, seems to match the first column. However, we are sending the person to Dominican Republic and to Sri Lanka, which is probably not what the person expected because he doesn't have the budget to go over there, right? And so on the last one, then we get everything right. Only France, Morocco, and pools. Similar results. This is really what I wanted to avoid, is this idea. A person click only on pools, and you display to him, so only pools in Spain. You display to him something on Spain, also near the beach, But here you're selling the nature, right? You're not selling the hotel and the comfort. So we actually want to stop this sale from being shown to this client. We want to show some pools. And we get very good results on the right column. And I really like these results because we even capture the fact that the person is really interested by small bungalows on the pool, as you can see on the top 2 images. So this is really good results for us. And so what's next was the next thing that we can do on this project. Well, we created a measure of attractiveness of the tags and the themes. And we answered a marketing question that the people over there had for a long time, which was, what image should we display for ski, for example? And they thought that showing the person skiing was actually bad, and that the hotel, interior of the hotel was actually promoting the product. And this is actually true. So you can see that the more you show the interior of the room, the more the sale is attractive. And the more you show the valley, the snowfields, the mountain, the less people will click on it and purchase something. So it's really interesting results. It means that though we are using advanced machine learning techniques, what all we do here boils down to improving business intelligence, right? Creating some interesting dashboard for marketing. But then we can go further, and that's what we would like to do. If you go to the website, you can see that we have several images for the same sale inside of the sale description. And the idea here would be, of course, to say, well, some people would prefer the interior of the room, some people would prefer to see the mountain. And so based on the preference of the person, I could probably pick the right image to display to him, making the whole home page totally dynamic with the client. And yeah, so to conclude, 3 points I would like to say are, first, do some iterative data science. Of course, we didn't start with deep learning. You have to start with simple approaches, put them into production, then iterate, evaluate the model offline, online, and get better results. Then about deep learning and transfer learning is the same as what's been said this morning. Do not do it if you don't need to do it. Probably you can do something else that is simpler and very powerful. Most of the money that we get, revenue that we get, does not come from the improving with the image. It comes from the basic recommendation engines. And then, of course, don't start from scratch. Don't try to redo your own architecture. Find some pre-trained models and use transfer learning. Transfer learning is really nice because it can kickstart really fast all of your deep learning projects. And also, a lot of data scientists are able to do that without knowing, without having a really depth knowledge of deep learning. Right? So that's my talk, and thank you very much.
Thank you, Pierre. We do have time for some questions. Okay, I have one. There was a feature in the ski that was saying outside swimming pool for a ski resort. Like one of your graphs showed that a swimming pool was interesting.
For the ski?
Yeah, so for the ski.
This one?
Yeah, swimming pool outdoor for a ski resort. This kind of features when you're going with your model, like when you talk with the business guys, wouldn't they say, well, how people are interested in that? Like, wouldn't they doubt the model if you're showing something that is more interesting than outdoors?
So, yeah, so I did not really look at exactly what we get here. It's more like the whole direction that you can see, because the themes, they are not that precise. So sometimes we can have swimming pool outdoor, meaning maybe it's just a jacuzzi, you know, not a real pool, right? It's just maybe water. So we don't actually, I did not fine-grain this analysis, but basically the interesting part here is indeed you get better performance if you show the interior of the room and not the people's skin, because a lot of people on this website, what they are looking is for the luxury part that I talked briefly about at the beginning. So what they want to see is, oh, this hotel looks really nice, and I have minus 75%, so I should go and buy it, right? If you see just someone skiing, you're like, yeah, he's skiing. That's probably the reason.
Okay. Questions? Oh.
Hi. You said you get a bunch of recommendation engines and get the output as features for a logistic regression, right?
Yes.
Just to optimize parameters and weights.
Yes.
What do you use as labels in the logistic regression?
It's a very good question. So I prepared the slides on this one. So what we do is we use negative sampling. So basically, we look at the past. We have around 6 months of data that we can use. And what we do is we look at all the purchase. All of the purchase can be described as user ID, sale ID, timestamp. And this is all ones. Now, we want to generate the zeros. And in a lot of paper, you can see that people just select random zeros over all the possible products. But in our case, that makes little sense because most of the products you cannot buy at this moment. So what we do is we look back and we look at all the sales or products that were available on this very day, which is around 700 products. And we sample 5 of them to generate the zeros. So that's what we do to generate all labels. So thanks, very good question.
We have time for one more question. Here.
Thank you. It sort of feels to me like when you're experimenting with machine learning, you can do it on a very small laptop. I don't even have GPU on this. If you're experimenting with deep learning, you have to have much more advanced equipment with GPUs and so on. Can you comment on experimenting with transfer learning and the infrastructure you had to do that, and how long it took, and is it somewhere in the middle?
So for the GPU part, we just open an Amazon instance, and what we're really interested about is if you open an Amazon instance and cut it like when you did, you can have powerful enough GPUs for the training part. The issue would be now we want to do that for real at the client, and to solve this problem, what we do is we actually don't use GPUs but CPUs. And the reason for that is we only have around 700 new sales per day. So it means that even if it takes 1 second to generate the labels for this image, then we don't care because 700 seconds is not that much, right? So we just use Amazon instance to generate or train our models, and then we just apply that on CPUs.
We still can have one more question. Okay, then let's thank Pierre again.
Thanks. Thank you very much.